Hi everyone, this is Steven, host of Computer Art Explorers. Welcome to another exciting episode of exploring how to create computer-generated art. Computer Art Explorers is both a YouTube channel and a meetup group. In this video, we're going to discuss how to scale and rotate images using some of the Sybos Bicubic image processing commands. Before we get started, we do want to mention that for the best viewing experience, please watch this video on a monitor having a resolution of 1920 by 1080 or higher. And you want to watch this video in full screen mode. Also, make sure that your YouTube settings are for high definition 1080. And to get started, we have this folder right here, this video number 0101 example. Now this folder is downloadable. There's a link in the comments of this YouTube video. I'm going to open this folder up. Notice that there's 3 files in here. Let's go ahead and take a look at what these 2 programs combined are going to create. And we've got the output art right here. I'm going to right click on it and hit preview. So this is what these programs are going to generate. It's going to generate this image of these 5 fish going in a circle. So this is a piece of artwork. Let's take a look at our actual image itself. So this, if I hit Control E, and this is the original MS Paint program, and it's showing you this image here. It's a bitmap 1500 pixels wide by 1500 pixels high. And I just want to point out that this fish is centered both vertically and horizontally within this 1500 by 1500 image. Let's talk about this adjustment that we want to make. Notice how the fish is actually angled down. In order to draw a line from the tail to the mouth, there's the angle that this fish is at. And what we want to do is we want to adjust this so that this fish is on the x-axis. We want the tail to the head to run along the x-axis. Just about like that. This line to this line, this is about 19 degrees. Let's go ahead and open up this Create Adjusted Fish Image source code. And before we talk about the code, I'm just going to go ahead and run it. So the first thing it's doing is displaying the original image. I'm going to hit Escape, and it's now displaying the rotated image. Let's talk about how we actually achieve that. The first part of this code here, we're just clearing the screen. The next thing is 2 graphic regions that we're creating. The first one is we're going to have the original fish image in it. So this here is naming the file. So here's the file right here. That's the name of the file. And so for the first parameter for the master path, a quote is just a null string. There is no master path. It's because this image happens to be in the same folder that our program is in. So we don't need to specify a path. So this command opens up the graphic region in the same size, that 1500 by 1500. And it is now this handle called GR original fish image is now our handle to that graphic region in memory. This next command, we're going to open up a second graphic region, and we want it to be the same width and height as the original. So the graphic region wide is going to return a value equal to the width of our original image, the graphic region high, the height of our original image, and the open graphic region command is going to be the width and the height that is specified by these parameters. And so there's your first parameter, comma, your second parameter. And it's going to return a handle, graphic region handle, to the second image. Now just because this is a variable, this GR adjusted fish image, this is a variable that's holding the handle to this graphic region. Just because we named it adjusted fish image does not mean it has an adjusted fish image in it yet. The fact of the matter is, if we were to place this on the screen and then pause our program so you can see what it is, it will just be black right there. All right, that's because black is just 0. Color 0 is black. And when you create a graphic region, it's just a chunk of RAM memory that is got a bunch of zeros in it. And if you display it on the screen, it's just going to be a black image. Now, move down to this next bit of code here. We're setting the angle at 18.9. That's what we want to rotate it. And we want to rotate it counterclockwise, so it's a positive number. If we wanted to rotate it clockwise, it would be a negative number. I'm setting that angle. This is a local variable that's holding the value of 18.90, and then it's being passed to this command here, the bicubic copy rectangle. And let's look at this command and see what it's doing. This command, under the purpose for all of these different commands here, these 4 different types of commands, these commands start the process of copying the source rectangle. So whatever the source rectangle is defined as, it's defining the source rectangle to be the entire original fish image. So the whole 1500 by 1500 image is a rectangle, is going to comprise of all of that pixel data. The target image is going to be yet another 1500 by 1500 that is going to be copied into. So this command is basically going to copy everything in the source to the target, but it's going to do it with the angle of rotation. So it's going to rotate it using something called bicubic interpolation. That's the process that is being used to, and you can Google that. If you want to understand more about how that works, you can Google that and it will explain it to you. But that's the process that the runtime engine is doing to take the source rectangle and copy it into the target rectangle. The next parameter here, the null pixel color, we're going to talk about this in a minute. For right now, we're just going to leave it white. And then null, there are 1 or more flags. We're not going to use any of the flags. We're not going to get into them. We just don't need them in this example, so we're not going to discuss it. But this command, this is the workhorse command. This is the command that is doing the rotation for us. Then this next line is simply going to place the graphic region. First thing we want to do is we want to look at the original and then pause. Then when I hit escape, as a user, if I hit escape, it will then clear the screen and then place the graphic region being the adjusted fish. And then it saves the target. When the target is the adjusted fish, it saves it to the file called adjusted fish image. So I'm going to go ahead and run this again and look at it one more time. Notice the frame was blue there for a few seconds. So that was the time it took the Sybos runtime engine to take all of the 1500 by 1500 pixels in that entire image and rotate it and copy it. So it's pretty quick. If it's really, really slow on your computer, chances are you got a whole bunch of junk running in the background. So if you got a bogged down machine, that's going to affect the performance. At any rate, and this was real time. There's no video tricks here. So that's real time on this machine. This machine is a very clean machine. It's got hardly anything on it, which means that the processing power can be used by the runtime engine. All right, so here's our original image. Hit escape, and once again, there is our corrected image. Now I'm going to go ahead and close this out. Here's our adjusted fish image. Let's go ahead and just preview that to see it. So there you go. All right, and if you want to preview the original, so there's our 2 images side by side. Here's the original fish image at an angle, the adjusted image, head to tail along the x-axis. Okay, now let's go ahead and take a look at this fish art example. All right, and in this example, we're hiding the master runtime window, and then we're going to clear the screen, and we're creating a new window, and we're going to maximize this new window. And just to show you, if I put a pause in here, notice how that button is gone. It says Sybos Runtime Platform, because that button only appears on the master runtime window. So since this is not the master runtime window, you don't see that. Come back in, take this away. All right, let's go ahead and take a look at this next section of code. So the variable GR fish image is going to hold the handle of the graphic region for just the adjusted fish image. That's what we're bringing in, and that's what we're starting with. We're also going to create an output graphic region. I decided to make it 940 by 940 pixels because it fits on the screen nicely. For example, if I bring this up, hit pause, sub, just so we can take a look at this. So right here, this is the output region. 940 by 940 fits nicely on the screen. Now, let's talk about this next section of code, because this variable here, we're setting equal to 5, meaning we want 5 fish. The size of the fish, I put 700, and it's not that the fish are going to be 700 pixels long or high or anything like that. What it means is it's the graphic region that we're going to copy the fish into. Remember, that's a 1500 by 1500 with a bunch of white space around it. And we're going to open another graphic region and just call it GR to hold the handle, the variable GR. And this region is going to be 700 pixels wide by 700 pixels high. So what happens is when we come down here to this bicubic copy rectangle, it's going to copy the source rectangle, meaning the entire fish image of 1500 by 1500, and it's going to copy that into a graphic region that is only 700 by 700, and it's going to be forced to scale it down to fit this. All right, so I'm pointing that out because somebody's going to look at the fish image and say, well, the fish is not 700 pixels long. Well, that's why. So this is the this command here. We're placing the graphic region on the screen so that we can see our output, whatever we copy into it. A for next loop. So we're saying for and then next. This is going to create a bunch of things. And let's look at this with respect to see this statement here, print the angle. So I'm going to go ahead and run this, and let's look and pay attention to the angles going through every time we go through this loop. Because the first time through the loop, the angle is 0. And at a 0 angle, notice the rotation of the fish, it scaled it down from the 1500 by 1500 image, it scaled it down to a 700 by 700, and it didn't rotate it at all because the angle is 0. The fish remains on the x-axis. Now, the program did that and hit pause. So I'm going to hit escape to go to the next image. And at this point, we're at 72 degrees. Okay, that for next loop, on the second time through that loop, it jumps up to 72 degrees. And so what you've got, if you notice, look at the fish. The fish on the fish's x-axis rotated counterclockwise 72 degrees. And here, this fish right here is 72 degrees rotated from the original. All right. Also, we're using 72 degrees. If you imagine a line from the center point of the graphic region going through the center point of the fish, and imagine that line, and then take another line and go from the center of the graphic region to the center of this fish over here. Imagine there's a line here and a line here, that the angle between these two lines is 72 degrees. And we're going to talk about how that works. Go to the next image. I hit escape to go past it. And we're now at 144 degrees. So again, this fish has now been rotated counterclockwise 144 degrees. And the center of the fish has been placed at 144 degrees from the line from the center point to the first fish around. So I think you're seeing the pattern here. The next one is 216 degrees, and the next one is 288 degrees. All right, and then I hit escape again, and it fills the background, turns the background color to white, and there's your image. all right, and then it saves it to output art. And that was the file we looked at the very beginning. So how is it doing these computations? That's what we're going to look at next. Okay, so the for next loop is creating the angle. That every time we go through that loop, and that's because the angle starts at 0, it goes to 359. So from 0 to 359 is 360 degrees. Remember, a circle, 360 degrees all the way around. The step command, it's saying, do this loop, but step it. And in this case, we're taking the 360 degrees divided by the number of fish. So if we were to change the number of fish, for example, let's say we were to go to 8 fish and reduce the size. Let's say if I reduce the size down a little bit. Now I rerun it. Watch what happens. And look at your angles. There's your angles. You've created 8 fish and you stayed in a circle. We come down here, and remember we were talking about the center of the fish, the X position and the Y position. This is where you use sines and cosines. There's a couple things I want to explain about taking a sine of something. And that is, in the Sybos language, notice that the angle is in radians. It expects whatever angle you're going to put to be in radians. Now, if you're not familiar with radians, 1 radian is equal to 57.29578 degrees. So, the sine function needs to have the input value in radians. So there is this command called in degrees. And what this is doing is it's taking my angle, which happens to be in degrees, and this is, I'm going to click on this here, and it's doing a conversion. Okay, the output value is in radians. That's what this function is doing. It's converting the degree value into a radian that can be passed into sine. And then the cosine is doing the same thing. So here we basically have the sine of the angle, the cosine of the angle, times 325. Now what that's going to do is that's going to give us an x and y value that is going to be relative to the center point of the screen. Because when you use sines and cosines, you're going to have both positive and negative numbers. So the x value at the furthest is going to be plus 325, because we're multiplying 325 by the sine of it, all the way to a minus 325. So that's giving us the back and forth. And then, of course, the cosine on the y is giving us the up and down value. From the center point here to the center point of the fish is the 325. Okay? Again, 325 pixels is the distance between the two. So that's how you can change it if you want to change the distance. Let's just go ahead and just do that just so you can see it. Let's say if we were to change it to, and let's say we only changed it to 250 on the y-axis. So you can see what happens. So you see how it's kind of smashed in and made more of an oval, all right? Because the distance from the center point to the center on the y-axis is 250. Well, we left it on the x-axis of 325. All right, now that's creating the fish center point, all right, relative to the center of the screen. When we actually go to place the image, what we have to do is we have to make some adjustments. First off, we have to say where we're going to place the target rectangle at is going to be at the output center. So this is our graphic region. Remember, our graphic region is here. We divide the width by 2 to get the center X position. We divide the height by 2 to get the center output position. So that gives us the X and Y coordinates for the center of our output graphic region. So we have to start, when we want the X, we have to start with the center point of the X. Then we have to add the fish center. So the fish center X is going to be swinging out one direction, plus 325, minus 325. So that's how taking these two here and adding these two is going to give you that. Now the reason why we have the minus the fish size divided by 2 is because the graphic region, when we copy it using this command right here, it is actually going to copy from the upper left hand corner of the image. All right, and that this is the math that's needed so that when you do this copy rectangle using OR logic, copying the graphic region GR, because we're defining that to be the source rectangle, and then we're defining the target rectangle to be the output graphic region, all right? And we're setting the X and the Y in the output graphic region, and we're saying copy this reduced fish size, right? We right here, we reduced the size of the fish, we rotated it and reduced it, and then we're copying it using this command here into our output graphic region. And then we're printing the angle on the screen. When the angle got printed, that was this command here, just printing it on there. We are updating the graphic region so that, because every time we make changes to the graphic region, we have to notify the runtime engine that, hey, changes have been made, or all the changes we're going to make have been made. Go ahead and repaint it on the screen. If we don't have this command, the changes will be made, but you won't see them. So this is it. This is the logic and the workhorse algorithm that is creating those fish, painting them on the screen, and creating that artwork. This is the logic that is actually filling it in. So let's go around. Okay, when we're right here at this point, imagine if you're in a paint program and you just want to use the fill command, and you want to fill at pixel 1, 1, you want to fill it with white. That's all it's going to take to fill everything. It's going to fill the whole thing full of white. And that's exactly what that did right there. All right. The only reason you really only need that, I could remark this out and it would do the same thing. The only reason that is there is to do a second fill using at the very center of the screen. And the reason for that, I'll put a pause here. I will take this pause out. As a matter of fact, I'm not even going to update the graphic region. Watch this. Let's see here. And we're going to change the number of fish. 12 fish. Okay. So there it did 12 fish. And then it filled in at your pixel coordinates 1, 1. But because the fish are overlapping, it didn't fill in the middle. So that's where the second command, I'm going to go ahead and hit the escape to go past it. And notice there, now it filled in the middle. The last thing we're doing is we're just saving it to the output art. So again, if we were to come down here, notice our output art, preview it, and there it is. Here's what we created. You could take the number of fish to 50. You drop the size down to 50 and see what you get. You get a bunch of little small fish like that. All right, well, that concludes this edition of Computer Art Explorers. If you like this video, please give it the thumbs up and go ahead and hit that subscribe button. If you want notifications when we post new videos, hit the bell button as well. And cheers.